If you look up at the night sky on a clear evening, and you know just where to look, you might spot a tiny light that isn't quite white like the other stars. It's a little bit red, a little bit orange maybe, like the last glow of a fire that's been burning down slowly all evening. That little light is Mars. It's been up there for a very, very long time, longer than anyone has been alive, longer than any building or any story anyone ever told. It just drifts along quietly up there, going around the sun just as we do, on its own slow, patient path. And for as long as people have been able to look up and wonder, they have looked at that little reddish light and thought, I wonder what's up there. I wonder what it's like. I wonder. Could we go? So tonight, let's find out. Let's go slowly, because there's no hurry. We'll wander through everything there is to know about Mars, gently and quietly, the way you might walk through a sleepy garden at dusk when the birds have just stopped singing and the air is soft and still. Close your eyes if you like, or just let them go soft and heavy. Everything is calm. Everything is still. Let's begin. Mars is the fourth planet from the Sun. That means if you were standing in space and could somehow look at all the planets lined up in a row, Mercury, then Venus, then us, then Mars. Mars would be the fourth little dot along. Not too close to the Sun, not too far. It sits there, at a kind of reasonable distance, all things considered. It takes Mars about 687 days to go all the way around the Sun. That's almost 2 of our years for one Martian year. So if you were a child on Mars, you'd only have had about half as many birthdays as you've had here. Isn't that funny? You might be 8 years old in Earth years, but on Mars, you'd only have had 4 birthdays. You'd still be waiting for the 5th one. And a day on Mars, the time it takes for the planet to spin around once, is almost exactly the same as a day on Earth. Just a tiny bit longer. 24 hours and 37 minutes, roughly. So, if you woke up on Mars in the morning, by the time the sun had crossed the sky and set again, just about the same amount of time would have passed as it does here. That's a comforting thought, isn't it? You'd still have morning, and afternoon, and evening. You'd still have that quiet, drowsy time right before dark when everything settles down. Now, Mars is quite a long way away from us. How far? Well, it depends on where both planets are in their journeys around the Sun, because sometimes they come closer together and sometimes they drift further apart. But on average, Mars is about 225 million kilometers away. That is a number so big that it doesn't really mean much to our sleepy minds right now, and that's quite all right. All you really need to know is that it's very far. Very, very far. If you were on a rocket ship heading to Mars, it would take you somewhere around 7 months to get there. 7 months of floating through the quiet dark of space, watching Earth get smaller and smaller behind you until it was just a pale blue dot, and watching Mars get slowly, slowly bigger ahead. Seven months is a long time. That's about as long as a whole school term, and then another one after it, and then a bit of the summer holidays too. Imagine sleeping and waking up and eating and looking out the window at the stars every single day for 7 months. It would be peaceful in a way. Terribly, wonderfully peaceful. Just you and your small crew and the deep quiet hum of the ship and the most enormous darkness you've ever seen in every direction. You'd have to take everything with you, of course. All your food, all your water, all your air. Because out there between the planets, there's nothing at all. Not a shop, not a river, not a breath of breeze, just the long, patient dark. Let's imagine you've arrived. 7 months later, your rocket has gently slowed down and come to rest on the Martian surface. The engines go quiet. Everything is still. You look out the window. The first thing you'd notice is the color. Everything is red. Or not quite red, more like the color of rust, or old terracotta pots, or the warm sandy earth you might find in a desert. The ground is covered in this reddish dust and reddish rocks, and the sky, which you might expect to be blue like ours, is a sort of dusty pinkish orange color. Not quite peach, not quite brown, something in between. It has its own strange beauty, like a painting done in warm, earthy tones by someone who is feeling very calm. Why is Mars so red? Because of iron. The rocks and the soil on Mars contain a lot of iron, and over billions of years that iron has rusted, just the way an old bicycle left out in the rain goes red and rough and crumbly. Mars is, in a way, one enormous rusty world. The biggest rusty thing you could ever imagine. And there's so much dust. Martian dust is very fine. Finer than flour, almost. And it gets lifted into the air easily, coating everything, settling on everything, drifting in great, slow clouds across the plains. Sometimes Mars has enormous dust storms that can cover the whole planet. turning the sky an even darker shade of orange and making everything hazy and still. These storms can last for weeks or even months. They are quiet storms, though. Slow and vast and patient, not violent, just big. Now, here is a wonderful thing about Mars. It has the biggest volcano in the whole solar system. The whole solar system, which means out of every planet and every moon and everything that goes around the sun, no volcano anywhere is as big as this one. It's called Olympus Mons. Can you say that slowly? Olympus Mons. It sounds quite grand, doesn't it? It should. It is grand. Olympus Mons is about 22 kilometers high. Our own Mount Everest, the tallest mountain on Earth, is about 9 kilometers high. So Olympus Mons is more than twice as tall as Everest, more than twice as tall as the highest point on our entire planet. And it's not just tall, it's wide too. So wide that if you were standing at the edge of it, the volcano would stretch out so far in every direction that you wouldn't even be able to see the other side. You'd just see flat land in front of you and not know you were on a volcano at all. It's so big, it sort of hides itself. But it's not erupting now. It's been sleeping for a very long time, Olympus Mons has. Just sitting there, enormous and quiet and still, under that dusty pink sky. And near Olympus Mons, there are other volcanoes too. A whole family of them, sitting together on a raised area of ground called the Tharsis Bulge. Isn't that a gentle sort of name? The Tharsis Bulge. It sounds like somewhere very comfortable to sit. Mars also has a canyon, a giant crack in the ground, called Valles Marineris. This is almost too big to imagine gently, but let's try. The Grand Canyon in America is one of the most famous and beautiful landscapes on Earth. People come from all over the world to stand at its edge and look down into it and feel very small and very quiet inside. The Grand Canyon is about 450 kilometers long and about 2 kilometers deep. Valles Marineris is 4,000 kilometers long, and in some places it's 10 kilometers deep. So if you put the Grand Canyon inside Valles Marineris, it would just disappear. You'd need to put about 9 Grand Canyons end to end to fill it. 9. It stretches across Mars like a long, slow sigh in the planet's surface. Scientists think it formed a very long time ago, perhaps as the Tharsis Bulge swelled up and cracked the crust around it, the way bread cracks gently when it rises in the oven. Just a slow, enormous shift in the rock over millions and millions of years. You could stand at the rim of Valles Marineris and look out across a view so wide and so deep that you would feel as though you were dreaming. And on a calm day, with that soft orange sky above you and the red dust stretching away in every direction, it really would feel like a dream. Now let's think gently about what it would actually be like to live there. Because Mars is beautiful in its own quiet way. But living there, truly living there, the way we live here, would be quite a challenge. The first thing is the air. On Earth, we breathe air without even thinking about it. We breathe in, and the air is full of nitrogen and oxygen and a little bit of other things, and our lungs take the oxygen out and give us energy, and we breathe out. And it all goes on without us having to do a single thing. It's wonderfully automatic. Mars has air too, a very thin atmosphere, but it's almost entirely carbon dioxide. That's the same gas we breathe out. So the air on Mars is, from our point of view, already used up. Our lungs would not know what to do with it. We would not be able to breathe a single breath of Martian air and be all right. So, if you were on Mars, you'd need to have your air with you at all times. You'd wear a spacesuit with a helmet, and the suit would carry a little supply of oxygen, and that would be your air. Every breath. And your home on Mars, your habitat, as the scientists call it, would need to be sealed and pressurized, with its own supply of breathable air kept carefully inside, like a bubble. A warm, safe, airy bubble in the middle of all that beautiful, breathable red. Nothing. The pressure of the atmosphere on Mars is also much lower than on Earth. What does that mean, pressure? Well, imagine the air as having a little bit of weight to it. It presses down on us and around us from all sides. On Earth, there's quite a lot of this pressure, and our bodies are used to it. It keeps our blood in order, in a way. On Mars, the atmospheric pressure is less than 1% of what it is on Earth. That's almost nothing, almost like being in space. Which means that even if you could somehow breathe the Martian air, the pressure would be so low that the liquid in your body would behave strangely. Your blood wouldn't stay where it should. Your lungs wouldn't work as they're supposed to. Your whole body would be very confused. So the habitat needs to not just have the right air inside, but also the right pressure. It needs to feel to your body roughly like being on Earth. And that's something that clever engineers can design and build. It's not impossible. It's just something that needs to be thought about very carefully. Now, there's the cold. Mars is cold. Quite extraordinarily cold. On Earth, We have warm days and cool days and cold nights and very cold winters. But even the coldest places on Earth, like Antarctica, have temperatures that our bodies, with enough warm clothes and shelter, can survive. The very lowest temperature ever recorded on Earth is about minus 89 degrees Celsius. Terribly cold. But Mars in winter near the poles can get down to minus 125 degrees. And the average temperature across the whole planet all year round is about minus 60 degrees. That is cold in a way that is hard to imagine while you're tucked in somewhere warm and soft. Minus 60 degrees. The kind of cold where the air itself would seem to freeze. Metal would become brittle and snap. Any water would be locked solid, hard as stone. And yet, Mars does have warmer spots. Near the equator, in the middle of a Martian summer day, temperatures can rise to around 20 degrees Celsius, which is actually rather pleasant. That's about the temperature of a warm spring day here. And you could stand there in your spacesuit, in the thin orange sunlight, and feel the warmth of it on your visor and think, this isn't so bad actually. If only I didn't need the suit. What about water? Life as we know it needs water. Every single living thing on Earth needs water. And Mars is mostly dry. Mostly. But here's a wonderful thing. Mars has water ice at its poles. Real water ice, mixed in with frozen carbon dioxide, sitting there at the top and bottom of the planet like great pale caps. From space, they look white and quiet and still, those polar caps, while everything else is red and brown. And scientists have found signs that Mars also has ice beneath its surface in many places. Water frozen into the soil, just underground, not in rivers or lakes or pools, but locked away, sleeping, waiting in the cold dirt. Can you imagine that? You'd be walking across what looks like a plain, empty, dusty red landscape, and beneath your boots, just a few meters down, there would be water. Sleeping water. Waiting. Scientists have even found signs, not certain but possible, of liquid water deep underground in very salty pools, kept from freezing by the pressure and the salt. Like hidden underground lakes, very deep and very cold and very dark. We don't know for certain yet. But perhaps, if there's water, that helps enormously. Water can be split into hydrogen and oxygen using electricity. The oxygen could be used for breathing, the hydrogen for fuel. Water can be used to grow plants. Water can be drunk, boiled, cleaned. Water is the beginning of almost everything a small settlement on Mars would need. Now, about the sun. Mars is further from the sun than Earth is, which means it gets less sunlight. About half as much, actually. The sun in the Martian sky would look smaller than it does from Earth. Not enormous and bright and warm, but a smaller, quieter, more distant light. Still enough to cast shadows, still enough to warm the day, but less. That said, solar panels, those flat, dark panels that gather sunlight and turn it into electricity, would still work on Mars. Not as well as on Earth, but well enough. And there's another good source of energy on Mars: nuclear power. Small, safe nuclear generators have already been sent to Mars, in fact. The rover Curiosity, which has been slowly trundling around Mars for over a decade now, still going, still quietly exploring, is powered by a small nuclear battery. It doesn't need sunlight. It just hums along, steady and patient, day after day, year after year on its slow Martian walks. Here's something to think about slowly. Mars has moons, 2 of them. They're called Phobos and Deimos, and they are nothing like our moon. Our moon is big and round and bright, and it rises in the east and sets in the west in a long, slow arc, and it lights up the night beautifully. Our moon has been up there for 4.5 billion years, and we have songs about it, and stories, and children have looked up at it from their beds since before anyone can remember. Phobos and Deimos are tiny. They're not round like our moon. They're lumpy and irregular, like potatoes. Phobos, the bigger one, is only about 22 kilometers across. Our moon, by comparison, is 3,474 kilometers across. So Phobos is tiny. It would look from Mars's surface more like a bright star than a moon, a fast-moving, slightly oblong, brightest star in the sky kind of light, and it moves fast. Phobos goes all the way around Mars in just 7.5 hours. So in a single Martian day, you'd see Phobos rise and set twice. It races across the sky, east to west, rising and setting before you've even had a chance to notice it properly. Isn't that funny? Our moon takes a whole month to go around Earth once. Phobos does it in 7.5 hours. Deimos is even smaller, and it moves so slowly that it hangs in the sky for days at a time before setting. On a clear Martian night, you might look up and see Deimos just hanging there softly, barely moving, while Phobos swoops past underneath it on its quick, busy circuit. And all around them, the stars, so many stars, because there's almost no atmosphere to blur them. They would be brilliant and clear and still, the most stars you've ever seen in your life. Scientists are already making plans for how people might live on Mars. Real plans, with real maths and real engineering behind them. One idea is to build the first habitats partly underground or under a covering of Martian soil. Why? Because Mars doesn't have a magnetic field like Earth does. Our magnetic field is invisible but enormously important. It wraps around the whole planet and deflects harmful radiation from the sun and from space. On Earth, we don't have to think about this at all. The field just quietly protects us, all day, every day, without our knowing. On Mars, the magnetic field is very weak. It doesn't protect much, so radiation from space reaches the surface more directly. But soil is good at blocking radiation. Even a few meters of dirt above a habitat would protect the people inside quite well. So, the first Martian homes might look, from above, like gentle mounds of reddish earth. And inside those mounds, warm and lit and safe, people would be going about their days, eating, working, reading, sleeping, in the most extraordinary place any human had ever lived. There are also ideas about growing food in sealed greenhouses, where the air can be controlled and the light can be provided artificially. Plants are wonderful. Given the right conditions, the right warmth, the right light, the right water, the right soil, they grow. They give off oxygen as they grow, which is exactly what the humans nearby need. And they make food. Potatoes, apparently, might grow quite well in Martian soil with a bit of help. There's something comforting about that, isn't there? Potatoes. In the middle of all that red wilderness, someone eventually growing potatoes. Some people dream of something called terraforming. That's a big scientific word that just means changing a whole planet to make it more like Earth. Making the air breathable, warming the temperature, bringing water to the surface, making it a place where you could eventually walk around without a spacesuit and feel the wind on your face. This is a very, very long-term dream. It would take centuries, maybe thousands of years. It's not something anyone alive today would see happen. But it's a beautiful thing to think about slowly, in the dreamy way one thinks about very big, very gentle ideas. Imagine, one day, so far in the future that no one alive now could possibly be there to see it. A child standing on Mars. And this child is not wearing a spacesuit. They're just standing there in ordinary clothes, in a gentle breeze, looking out at the red rocks and the wide Martian plains. And above them, the sky is slowly, slowly becoming more blue. Not as blue as ours, perhaps more of a violet blue. But blue. And somewhere nearby, there's a small green plant growing in the open air, in the Martian soil, under the smaller, quieter sun. That child would be so far from anyone who had ever lived on Earth that they might feel, sometimes, quietly homesick for a place they'd never been. and they might look up on a clear night and find a pale blue dot among the stars, the way we look for that little red light now. And they might think, that's where it all started. That's where people came from. And they'd feel that same quiet wonder that we feel now looking at Mars. You know, we've already sent quite a lot of things to Mars. Lots of robotic explorers, rovers and landers and orbiters have been traveling to Mars for decades. Some have flown past, taking photographs as they went. Some have gone into orbit around the planet, mapping it from above in great detail. And some have actually landed on the surface. The first successful landers touched down in 1976. 2 spacecraft called Viking 1 and Viking 2. They settled gently on the Martian surface and looked around with their cameras and did experiments and sent back data for years. They were the first human-made objects to sit on Mars and say, in their quiet mechanical way, "Hello, we're here." And then, years later, rovers began to arrive. Little robotic vehicles that could actually drive around and explore instead of just sitting in one spot. The first ones were quite small. Then came bigger ones. Then came Curiosity, which is about the size of a small car, and it has been driving around a Martian crater called Gale Crater since 2012. It's still going. It drives a little bit, takes some photographs, uses its instruments to analyze the rocks and soil, and sends all its findings back to scientists on Earth. And then, more recently, came Perseverance, a newer, more capable rover, and with it, a tiny helicopter called Ingenuity. A helicopter on Mars. It was only the size of a small box with 2 small rotors on top, and it flew, really flew, lifted off the Martian ground for the first time in April 2021. The first powered aircraft to fly on another planet. It was designed to do 5 short test flights. It ended up doing 72. 72 little flights across the Martian surface, quiet as a dragonfly in the thin Martian air. Isn't that wonderful? A tiny helicopter going on its 72nd flight on another world, all by itself. So could we live there? Really, truly live there? The honest answer is, not easily. Not yet. Mars asks a great deal of anyone who would try. It asks you to solve the air, and the pressure, and the cold, and the radiation, and the water, and the food, and the distance, and the dust. It asks you to carry your whole world with you in a little sealed bubble of warmth and air in the middle of its vast and beautiful emptiness. But none of those things are impossible. They're just hard. And people have done hard things before. People crossed oceans in small wooden boats, not knowing what was on the other side. people figured out how to fly, how to go faster than sound, how to leave Earth entirely and walk on the moon. People are rather good at doing hard things when they decide they want to, and Mars is worth it in a way that's hard to explain but easy to feel. There's something about that little red light in the sky, something patient and mysterious and welcoming about it. It's been waiting up there for billions of years. It has its enormous volcano and its great canyon and its quiet rusted plains and its ice and its thin whisper of an atmosphere. It has its two small, lumpy moons racing across the night. It has its cold, still, dusty mornings, and its orange sunsets, and its brilliant starry nights. It's not home. But maybe, one day, slowly and carefully and cleverly and with a great deal of patience, it could become one. And now the story is nearly over, and the stars are very bright outside, and somewhere up there, if you know just where to look, that small reddish light is drifting along its slow path around the sun. Patient, quiet, beautiful. Maybe the people who will one day live on Mars are children now. Maybe they're going to sleep in a room not so different from yours, and they'll grow up and study and dream, and one day they'll step onto a rocket and go on the longest, most wonderful, most sleepy 7-month journey through the quiet dark of space. And when they arrive, they'll look out the window at the reddish plains and the pale orange sky and the enormous stillness of it all, and they'll feel something that is somewhere between awe and peace. And maybe they'll think for a moment about a story they heard once when they were very small and very tired and tucked in somewhere soft and warm, about a red planet far away and whether anyone could ever live there. And they'll smile. And they'll know the answer. The sky outside is soft and dark. The stars are where they've always been. Everything is quiet and still and very, very calm. The little red light is still there, if you want to look for it. But there's no hurry. There's no hurry at all. Sleep well.